While generating elongation information for curved hull plates is actually a very simple and straightforward process in terms of the options selected, understanding the overall workflow will provide context as to how this information is ultimately used on the production floor. Here we discuss the workflow from creating the plate using an existing hull model to expansion and exporting the plate to structure. So, what is the goal for creating elongation information? We want to provide the Nieland Press operator with elongation markings or values on curved plate stock in the form of marklines so that they can use this information as a reference when pressing or stretching plates using the Nieland Press. Generally, stretching employs the English wheel as opposed to a bending or stamping press, although it's ultimately up to the operator on how they use the elongation information. The first place to start will be with the stock catalog, but even before that step, we're making a number of assumptions. A, that the production team is aware of the reference table values used by the Neiland Press operator to cross-reference the appropriate values based on the elongation information we're providing. B, that the engineering team has already determined the appropriate stock materials to be used for the curved plate sections of the hull. C, that the max and min strain values have been assigned to these materials within the stock catalog. D, that the hull model has already been imported. And E, that the modeler is already familiar with the markline workflows as well as the plate expansion process. Within Manager or SC Catalog, we open the Structure Stock Catalog window, and for each type of plate material, we can view the attributes. Scrolling to the right, we see the max and min strain values. The defaults for the training project are set to plus or minus 0.5, but as stated, we're assuming these values have been calculated and entered appropriately beforehand. Elongation information may be conveyed to the press operator in the form of marklines or datum etched directly to the plate during the NC Pyros processing of the nested stock material. Alternatively, elongation information may be provided to the press operator as a set of plans detailing the overall shape and elongation information. In either case, these marklines are considered to be the equivalent of any projected markline applied to curved plates and are modified in Manager under the Structure tab, Plates, and Markline Styles dialog. While the elongation data values themselves are important, the actual projected elongation lines are not necessarily required. Therefore, the NC Pyros process value should be set to no process for the line and mark for the text. After selecting the Assign Styles button, we scroll down to the Curved Plate Markline designation and can see that the marklines assigned to curved plates are named Continuous. Note, modifying the marklines for curved plates will affect all projected marklines in curved plates, so ensure this change will not affect any other NC Pyros process. Currently, there's no way to add an alternate markline style for elongation specifically, only for all projected curved plate marklines. Apply and close the Manager windows. There are a number of steps involved in taking the source hull form from NURBS curves imported into ShipConstructor to an object in the project that can be added to a nest with elongation information ready for the production floor and ultimately pressed into shape. Each of these steps require the modeler or project manager to be aware of the potential issues that may arise and the possible solutions to resolve them. First, a curve block is formed from the hull model using NURBS curves. The resulting curve block is then used to generate the curved surface. The curved surface is expanded and elongation marklines are added. The curved plate is exported to Structure. The curved plate in Structure is added to a nest. Markline information is exported to be used to program cutting and etching of stock. And finally, elongation markline information is used by a press operator to shape the plates into their final curved shapes. From the NURBS curves that make up the hull model, curve blocks are formed, and ultimately hull surfaces. Once the hull surface is created, stock is then assigned. We're not going to go over the details of this process specifically, but only showing the stages in the workflow. Once the surface is generated and stock has been assigned, the plate expansion takes place. In most cases, for plates with very basic elongation along one axis, for example, this process will be straightforward. In other cases, though, during the expansion process, you may be presented with a warning that the expanded plate may be deformed as the surface mesh is out of square. To view the expansion mesh, within the Plate Expansion Options dialog, ensure the Show Expansion Mesh checkbox option is selected. While there are a number of ways to address this, including trimming or creating seams in smaller plates, the most efficient method will be to use the SCSURFSQUARE command, which recalculates the surface mesh to the nearest square values and then assigns the surface to the most appropriate orientation for efficient expansion. This can be a complicated concept, but essentially, while non-squared expansion uses the global coordinates to determine the expansion calculation, a surface that has been squared is more accurately aligned with the ultimate axis used during the forming or stretching process, usually along one of the two edges of the plate itself. You can see here that without the SCSURFSQUARE command, the ISO lines align with the original plate geometry and is not aligned with the axis along which the plate should be expanded, that is, along the logical expansion direction of plate edges. After running the SCSURFSQUARE command, the expansion lines then align more closely with the final projection axis one would expect during a standard expansion calculation. Selecting the hull surface that has been squared, we right-click and choose Expand Surface. The Plate Expansion option window appears, and the option to select either Nieland Press Center or Nieland Press Side is available within the Stretch Expanded Plate section. In this example, it may be obvious that the elongation process will be from the center, but it may also be from the side. It will be up to the modeler to confirm the required values the press operator will use in each case. Here we are not covering the specific cases as to when to employ either option, only that these are available. With that being said, you may wish to generate both expansion options and decide at a later stage which one to add to the production drawings and nests for NC Pyrus processing. Note that you cannot export both of these expanded plates to structure, as only the last one created would be a valid plate expansion object. The process of creating both here is simply to be able to view the differences in elongation values at this stage, and then to decide on which option suits the elongation process. Here's where the additional options also come into play. If you select the Delete Old Expansion Marks or Delete Old Expanded Geometry, each time you expand a plate, the previously generated expansion marks or object is deleted and replaced. Uncheck these and generate both the side and center expansions. In addition, selecting the Specify Plate Position and Orientation allows you to place the object anywhere in the viewport. So now you'll have the plate expansion generated, complete with elongation information within the hull module. It's at this stage that we need to format the mark lines in such a way so that we display them appropriately. Referring to the previous section on setting Markline NC processes, we can open Manager, select the Plate Stock Catalog and Markline Styles. Selecting the continuous Markline style, we can view the NC process specifically for the properties which control the general marking properties and set this to No Process. For the text property, we set NC process to Mark. This will ensure the elongation values are included with the NC Pyrus code that's exported, while not including the actual elongation lines, which require additional tooling and are simply not needed during the forming process. Right-click on the expanded plate and select Edit Markline Properties. Expand the Markline tree until you can view each Markline plan projection. Here you can edit label, colors, and other properties prior to exporting to structure. Finally, there are two additional tools available for further analysis and comparison of the surface itself: the deformation table and the strain map. Where elongation information provides stretching values along a single line across the surface, the deformation table provides a much more detailed summary of deformation values across the entire plate. The name column values correspond to the individual elongation datum as seen on the expanded plates. The strain map, on the other hand, provides a quick visual cue that highlights areas with the maximum and minimum strain values. As the goal of generating elongation information is to provide the press operator with the necessary reference values and information to create appropriate plate shapes, the final step is to generate output files that can be used on the production floor. Currently, there are three options for viewing the elongation information for production. A, having the markline and elongation values etched to the plate itself for reference. B, generating a PDF containing just the values and marklines. Or C, generating a PDF displaying the strain map along with the elongation datum and information. The default behavior when adding elongation information is that it will be added to the model, and you can set the NC Pyros to either mark or no process in Manager, Structure tab, Plate, Markline Styles, under the Properties or Text NC Pyros option, depending on if you want it etched during the cutting process or just visible in the model. The next option will be to export or plot the elongation information to a PDF to be printed as a reference guide for the press operator. Within the Layout tab within the hull drawing, create 4 viewports, selecting the model space for each, and then orientating the views to align in 3 of the viewports, and a perspective projection in the 4th to provide the necessary details required to obtain the overall shapes. From the AutoCAD menu, or using the plot command, export this layout view as a PDF. Export the same layout, but with the additional strain map visualization added as an additional reference. Within one of the viewports, select Model Space and select the plate. Right-click and select Show Strain. Modify the strain ranges if necessary. As strain mapping is not an object property that is saved to the model itself, we must generate the PDF using a slightly different approach. Using the Plot command, open the Plot dialog for the layout. In the Printer Plotter Name dropdown, select DWG to PDF. Change the Plot Area option to Layout. Select Preview. Ensure the preview matches your intended output. Press Enter, and then press OK. This process will generate a colorized view with the strain map included, which can then be added to the press operator reference package. So, while generating the actual elongation information is simply a matter of selecting the side or center options within the plate expansion dialog, the full process involves a number of configuration steps to complete. For more information, visit the online manual.